How are you doing your as-built measurements today? If you're like most people, you're probably doing a lot of hand measuring, which is very tedious and time-consuming. Then, at the end of the day, what are you left with? Inaccurate and incomplete data. 3D laser scanning changes all of that. With 3D laser scanning, we can create a highly accurate three-dimensional model of the complete interior and exterior of this building that we can then use inside of our CAD application to do our renovation. We start by positioning our 3D laser scanner on the site to be captured. Now we will run the scanner to capture the first scan of the building. To capture the scan data, the scanner uses a laser that is bounced off of a spinning mirror to measure the distance to the point the laser hits to an accuracy of 2 millimeters. As the mirror spins vertically, the scanner captures a column of data, and as the scanner rotates horizontally, it captures a complete 360-degree dome of points. The scanner can capture up to 976,000 points per second, and the final collection of points we call a point cloud. Next, we'll move the laser scanner to the next scan location. Since the scanner can only capture what is within its line of sight, we typically move the scanner around both the inside and the outside of the building that is being scanned to fill in the missing areas and create a complete point cloud. Before capturing the next scan, we will position targets in the direction we are moving the scanner to tie this scan location to the next. These targets will be used to automatically combine the multiple scans into a single dataset of the complete as-built condition. Now we are in Ferrocene, the software that comes with the scanner and is used to process the scans. Here we are looking at the data captured at one of the scan locations. This is a sort of panoramic image looking from the point of view of the scanner. We could also look at the scan in a planar view, which takes the sphere of data and unrolls it to look at the entire scan at once. Even though this looks like a photograph, every pixel in this image is a three-dimensional point captured by the laser scanner that we can use to take measurements. When measuring from the floor to the ceiling, the dimension is broken out to give us the true vertical measurement. Now we are no longer looking from the point of view of the scanner, but are looking at the true three-dimensional point cloud of the captured data. As we zoom out, you can see the amount of data that were captured from just a single scan location. After all of the scans have been registered together using the targets that were placed in the field, the complete point cloud can be seen. From here, we can export the point cloud to our downstream applications for use in planning and design. When using any of the Autodesk products, we will bring the point cloud into Autodesk Recap. Recap is a high-performance point cloud visualization engine that is not only a standalone application, but is also built into many of the Autodesk design suites. We can use the Recap application to view and navigate the point cloud. By cutting sections of the data, we can view the model in ways that would otherwise be difficult using data collected with traditional means of as-built surveying and measuring. Here, we are cutting a cross-section to view the floor-to-floor relationships and to determine the distance between the floors. We can get an understanding of the interstitial spaces and the ceiling plenums. Recap can also be used to take measurements and make markups of the point cloud. We can measure a point-to-point distance in 3D, a distance perpendicular to a face, or to the center or edge of a pipe. Now we are in Autodesk Revit, where we can attach the point cloud to a project as a link. We're going to start by creating a section view to align the point cloud data with the level datum lines that we established for the first floor and second floor of the building. This will allow us to create accurate floor plans for modeling the building to create a complete building information model. Looking at the floor plan view, we see the plan section is cut all the way to the floor level, so we can see the floor's materials and finishes. Here, we're going to adjust the view range to clip the view just above the floor to create a floor plan. And now we're going to do the same for the second level. The elevation views created from the point cloud are true orthographic representations of the building. This is difficult to capture with traditional photography. By working in context of the true as-built point cloud data, we can plan renovations and adaptive reuse projects and coordinate construction projects. With only a small amount of effort, we can create a rich and precise building information model that accurately represents the actual building conditions. Switching now to another project, let's look at an example of how we can use Autodesk Revit to work in context of the point cloud data to do an architectural renovation study. This is a laser scan taken in the lobby of a historic 19th century hotel. Here, we're looking at a 3D view of the model in Revit, and we're going to clip the roof off of the building to look at the interior of the space. Here on the floor plan, we're going to take a section through the hallway to look at the area where we will be doing the renovation. Creating a perspective view allows us to get a sense of the space and the design requirements. We can move and look around the space in real time. Now, let's do a renovation to the space. We're going to add a new wall with a door here between these columns. Notice that we can snap and track from the point cloud to make drafting easier. Looking back at the 3D view, we get the proposed new wall in the context of the existing space. Back in the section view, we see the wall and how it relates to the space vertically. In the perspective view, we see the proposed new wall as it would appear in the final renovation, and we can move around to explore the area and get an idea of how the proposed design will affect the existing space. Now, let's change the door and see how that changes the look and feel of the space. Call DLT Solutions today to find out how laser scanning can help you get fast, accurate, and cost-effective as-builts for your renovation project.